universe is a big place, and huge things happen in it. One of these things is stellar nucleosynthesis, which occurred all throughout the universe and formed the elements of life in the cores of stars. Later, these were spread out through supernovae. Although we need some heavy mathematical machinery to truly understand the physics behind this concept, we can still understand it.
Stellar nucleosynthesis is the process which describes how the elements in our solar system are formed. The main evidence for stellar nucleosynthesis comes from the composition of our solar system. The lightest elements, up to lithium, are formed during the Big Bang. The heavier elements, however, including the main elements of life, such as oxygen and carbon, are formed within stars where great temperatures and pressures are present. They form via fusion reactions, which are spontaneously occurring reactions where energy is released. This energy later fuels the stars. Via these fusion reactions, all the elements up to iron 56 are formed. For example, in a red giant star, there might be multiple reactions where elements are formed. Generally, the number of simultaneous reactions is pressure and temperature dependent. For example, at the top layer, we might have hydrogen and helium production. In the next layer, nitrogen is going to be produced, and so on until the core of the star is filled with iron and nickel. Then the star explodes and the elements are scattered throughout the universe. Here is an example of fusion reaction. Two carbon atoms produce oxygen, which then reacts with helium to produce neon, and so on up to magnesium. Then, for example, two oxygen atoms produce magnesium, which then becomes silicon, after finally sulfur is produced. Now let's see how the main elements of life were formed in fusion reactions. Four hydrogen atoms, under great temperature and pressure, spontaneously react to produce helium. Then probably in another layer of the star, three helium atoms will react to produce carbon, and finally carbon and helium will react to produce oxygen.
Now that we know that the elements of life were formed in stellar nucleosynthesis, what is its relevance to life as we know it on Earth?
Now that the elements of life were formed in stellar nucleosynthesis, what were the conditions of the primordial Earth that led to the formation of more complex molecules? An Earth with high volcanic activity and skies with numerous lightnings provided the energy needed for these simple molecules to react, bind, and evolve. This phenomenon was studied in the lab using the gases of the primordial atmospheres and sparks to simulate lightnings. After a few days, organic molecules were obtained. This famous experiment is known as the Urey-Miller experiment, and it implies that complex molecules could have formed in a primordial atmosphere, and it is not the only one of its kind. These organic molecules formed are the building blocks to even more complex life molecules, like proteins. Which brings us to the question, could a similar situation might have happened, or is it happening somewhere else in the cosmos?
Now that we know that organic molecules that made life possible on Earth were formed by the elements of life that are made in stellar nucleosynthesis, what does this mean for life in the entire universe? We know that life is a big numbers game. We know that stellar nucleosynthesis formed the elements of life, which gave the possibility for organic molecules to form under certain conditions. Might these conditions be elsewhere out there as well? For that, we have to look up in the sky.
Astrobiology is the study of the origin, evolution, distribution, and future of life in the universe. This includes not only extraterrestrial life, but also the type of life we find ourselves to be a part of. By studying all manners of life we find around us, astrobiologists work on understanding whether life exists beyond our home, and if so, how we can find it. When you think of just how complicated and diverse life is here on Earth, it's easy to feel overwhelmed by the seemingly infinite amount of shapes and forms life can take. To combat this, astrobiologists work with three main assumptions, formulated after studying the only form of life we know exists. 1, that life is based on carbon chemistries, 2, it depends on liquid water, and 3, it forms around sun like stars. With these assumptions in mind and the recent advances in astrophysics, astrobiologists have calculated estimates for how many places could host life in the galaxy. For example, the Drake equation provides a very rough estimate for the number of civilizations in our galaxy with which radio communications may be possible. Even with the massive inaccuracies in his equation, the chances are huge that we are not alone. And those chances have warranted many expeditions into space. Numerous missions are underway as we speak in an attempt to catch a glimpse of extraterrestrial life. Despite this, We still have no idea what lies beyond our home. All we can do is keep searching, and who knows what we might find.